Hello, Namaskar, Vanakkam. Welcome to CBSE with Sudhir, where we are continuing with the science syllabus as per the Curiosity NCERT textbook for students of class 8. What we are going to study in this chapter is the fascinating chapter about our skies. Keeping time with the skies, we will learn about how the calendar came into being. Why is it that, let's say, a festival like Eid comes at different times of the year every year? If one year it comes in the month of July, the next one it will be June, then May. It keeps changing. Why does that happen? Also, the changing phases of the moon. That's what we are going to study in this particular chapter. Now, it starts with a story about Makar Sankranti. Makar Sankranti, I'm sure all of you associate with flying the colorful kites. So, the story is about Meera was in Ahmedabad, and Ahmedabad sees a major kite festival. Kites are associated with Makar Sankranti both in the southern part of India and most definitely in Gujarat for the International Kite Festival. Now, as she looked up at the sky, which was filled with colorful kites, she noticed that the moon was shining during the daytime, that while it was evening, she could actually see the moon also. And she wondered to herself that she always thought that the moon appeared only in the night when it was dark. Why was the moon making an appearance during the day? She thought there was something very odd. She knew that the moon is spherical and shines by reflecting sunlight. Then why isn't the whole moon visible every night? What causes the moon's changing shapes? That's what we are going to study in this fascinating chapter. Why do I use the word fascinating? The adjective fascinating for this chapter is because, see, when you look at things on earth, they are things which you could possibly physically touch and feel and see closely. This is something millions of kilometers away, right? And yet you are able to see, you are able to send satellites into space in order to study them more closely. And isn't it fascinating that we are able to gain so much of knowledge about the sun and the moon and the different planets from our position on Earth? In fact, I have said this before in, I think, your class 6 or class 7 videos. My project in class 12 was on astronomy. So therefore, I have a special connection with the outer space. And I've also spent a lot of time at ISRO. So I understand how, at least to a little extent, how this entire thing works. So the explanation to the question that Meera had was that the moon is visible because it reflects sunlight, but only one half of the moon is always illuminated by the sun. So if this is the sun and if this is the moon, only one side of the moon will be illuminated by the sun. The other half will be dark. So if the earth is here, you will actually not be able to see the moon or see only a little part of the moon if it is not completely illuminated by the sun. I'm going to explain this in detail. You will need to understand this. I'm going to go slow when I come to that portion so that there is no doubt. This is the part, the first part. I'm going to actually revise it in the same video. See, this is the earth. We are here. This is the sun, right? And this is the moon. Okay. Now what happens is that the sunlight is falling on the moon and the moon is reflecting that sunlight. Please remember, unlike the sun, the moon does not have any light of its own. It is only a reflector of sunlight. Now, what happens is that when the sun's light is falling on the moon and it is completely exactly in line with the sun, then the entire half is getting illuminated. What we see from this side is therefore the dark side, and therefore we are not able to see the moon at all on that particular day, which is known as new moon day or Amavasya, which means no moon is visible. Does it mean that the moon has disappeared for one day? No, it just means that the moon is not visible because the darker side of moon is what is facing the earth. Is that clear? Now, as the moon moves this side, when it comes this side, now you see the sun's light is falling at an angle, right? At an angle. So therefore, one half of the moon is what is going to be visible. Then it comes here, right? When it comes here, you will realize that the sun's rays are completely hitting the entire phase which is facing the earth, and therefore that part will be the full moon, Purnima, which is the full moon which is visible. And again it goes to this side where again the half side is visible, right? So that's how the four phases of the moon actually operate. So as the moon revolves around this earth, we see different portions of this illuminated half from our position on earth. This makes the moon appear to change shape, giving rise to the different phases of the moon, such as crescent, half moon, and full moon. This is the the new moon. Then you have the half moon, the full moon, and the different crescent shapes which are formed when they are moving from this side to this side, from this side to this side, right? So that's how it happens. Now, it depends, as I said, that what I wrote, the operative part is it depends on our position from the earth. So it all depends on how, with the angle at which we are seeing the moon and the moon's relative position with the sun. Now, the moon can also be seen during the day when it is above the horizon. That is, horizon means where the sunrise actually takes place, the line, okay, and bright enough to be visible during the daytime sky. So that's how, when it is above the horizon, you can still see the moon during the daytime. Now, this is for students who want to understand which question bank to buy. This is the question bank that we are recommending, the Oswald Books question bank. This is the discount coupon code that you can use on oswaldbooks.com. Alternatively, you can use the link which I have given in the description box to go to Amazon in order to buy. High time, you should buy one quality question bank. As I said, if you have already bought some other question bank, please go ahead with it. Do not waste your parents' money to buy this question bank just because I am saying it. Please go ahead with it. Make full use of it. This, according to me, after having checked 5 different question banks, according to me, this one is the best in terms of accuracy in comparison to the kind of mistakes that you find in many other question banks. In terms of the number of, in fact, only yesterday I had gone to one of the bookstores here, and he said this one sells the most. The question banks of Oswald Books sells the most. So this is what I'm recommending. So please go ahead and buy it for students who want notes, mind maps, test papers, answers to the questions of your NCERT, and several other question bank. Okay, part of the question bank. Let's get back to the moon and the earth and the sun. Now, the phases of the moon. The changing shapes of the bright part of the moon as seen from the earth are called the phases of the moon. So some days, some nights you will see the moon like this, right? Like this, where the thickness is increasing, which means you are seeing more portion which has been illuminated by the sun from your position on earth. Then this will be when it is at that 90 degrees, when it is at that 12 o'clock position or the 6 o'clock position, right? What we saw a little earlier, right? You know what I mean when I say the 12 o'clock. Yeah, this is what I'm going to refer to as. This is the 3 o'clock position. This is the 9 o'clock position. This is the 12 o'clock position. This is the 6 o'clock position, right? So I will refer to it like this so that it becomes easy for you to remember. Now, so this is at the 12 o'clock and the 6 o'clock position. This is at the 3 o'clock position. This is between the 12 o'clock and the 3 o'clock position, let's say at around 1:30, right? So this is how it works. So this is how you are seeing it from your position on earth. Now, the waning period, which is known and in our native Indian languages as the Krishna Paksha, is the 2-week period, 14 days, where the bright portion of the moon decreases from a full circle to nothing. From a full moon, it will reduce to half moon, it will reduce to crescent, and then it will become the Amavasya period, the new moon period, right? So this is known as the 2-week period when it is waning. Waning comes from the word wane. W-A-N-E. Waning means to reduce. Okay, it's a synonym of reducing. So this is the waning period or the reducing period from the full moon, from the Purnima to the Amavasya, and this takes 2 weeks. Okay, this is known as the Krishna Paksha. The next one is known as the Shukla Paksha, which is the waxing period. That is, it goes from the 3 o'clock position, to the 9 o'clock position. So it goes from this position, it gradually gets a little bit of the moon is visible, then half moon is visible, and then back to the full moon, that is the 9 o'clock position. So the 3 o'clock position to the 9 o'clock position is known as the Shukla Paksha, which is the waxing period where more and more part of the moon starts getting visible to the human eye from the earth. So the 2-week period, this also takes 2 weeks. So 2 weeks plus 2 weeks is what we are talking about, where the bright portion increases from nothing back to a full circle. Is that clear? Now, the full moon day, which is known as Purnima, is the day the moon appears as a complete bright circle. You can see it will look huge and it is a beautiful sight, the Purnima, right? Then the new moon day or Amavasya is the day the moon is not visible and you would be able to see the moon is dark. I mean, the sky is dark at night because there is no moon which is visible from the earth. Then the crescent phase, like this, when less than half of the illuminated portion is visible. That is, only this part of the moon is reflecting the sunlight. Okay, so this is the crescent shape. Then you have the gibbous phase when more than half of the illuminated portion is visible. That is, more than half. This is the full Purnima, but if half of it is visible, then it is known as the gibbous phase. So now, as per your book activity 11.1, what you are expected to do is that you start a day after the full moon, observe the moon daily at sunrise for 15 days. So you will need to get up at around 5:30 or so. Then at sunset for the next 15 days, record the date, time, size of the bright portion. I remember doing all this when I was doing the project in class 12, and its distance from the sun. So 15 days plus 15 days, the moon's shape and its position in the sky relative to the sun change every day in a predictable cycle. That's what you will find. That's the activity you are meant to do. So on a full moon day, the moon, and this is again a very important aspect, on the full, and this is, you can now relate it to the 9 o'clock and the 3 o'clock position, right? On a full moon day, that is in the 9 o'clock position, the moon is opposite the sun. It rises when the sun sets. It is, opposite the sun. That's why it is getting the full face of the sun as it is visible from the earth. A waxing moon is easiest to spot, and this is something which you need to remember, that it is at sunset you will find it easier to find a moon which is waxing, that is increasing its kind of illuminated phase. Whereas a waning moon is easiest to spot at sunrise, where it is going from a Purnima to Amavasya period. That moon is easier to spot at sunrise. This is something which you will need to remember. Now, this basically, it's to do with the movement of the sun, movement of the moon, and the angle at which it moves. It basically depends on that. Slightly technical, so I'm not getting into that. Now, the moonrise time, the moon rises about 50 minutes later each day. This is because, this is a reasoning question, this happens because as Earth rotates once in 24 hours on its axis, the moon moves ahead in its orbit. Earth must rotate a bit more for the moon to appear in the same spot, which is why there is this delay of 50 minutes for the moon every day. So we may see that the moon is late, whereas it's not that the moon is late, the earth is taking, because it's all about, when you see it, right? So the earth is taking more time in order to rotate every day, and that alignment doesn't happen. So as a result of which we feel that the moon is rising 50 minutes late every day. We get that kind of a feeling. Now, the moon's physical shape, and this is something so that there is no doubt, because this is a very common doubt among students. So I put it as a separate slide, that the moon's physical shape never changes. It's not as if the moon shape is changing. Only the amount of its illuminated side facing the earth changes. Please remember this. This is the key phrase. That is, only the amount of its illuminated side facing the earth is what is changing. Half of the moon is always lit by the sun, while the other half is in darkness. Now, in order to understand it better, you can do this kind of an activity yourself, where you put in a light here to denote the sun. Use a ball on a stick to represent the moon and a lamp for the sun. Stand in the center as though you are the earth and move the ball like this, and how the ball gets illuminated by the lamp will kind of give you an idea at the 12 o'clock, 9 o'clock, 6 o'clock and 3 o'clock position to see how the ball is getting illuminated, right? So you need to have that kind of a ball which will get illuminated, and in a dark kind of a space you will be able to see the different crescent and the gibbous phase you will be able to see. This is another activity which I would suggest you should do it in a lab. So if there are any teachers listening to this, do this. It's always very fascinating to teach in the form of experiment. At least that's how we learned when we were in school. Now, why does the illuminated portion decrease when the moon is closer to the sun? Because as the moon moves closer to the sun's direction in our sky, we are looking more at its darker side, that is the face, the side which is facing away from the sun. So this is the reason why we find that the illuminated portion decreases when the moon is more close to the sun. Now, what happens during the Amavasya? The moon comes between the earth and the sun. The sun lights up the side of the moon. This is the sun. This is the moon. This lights up. The earth is seeing completely the darker side. So the side facing the earth remains dark. Is that clear? That's why illustrations become important, because you are able to relate to them much better than some of them which have been given in your textbook. Therefore, we cannot see the moon from earth, or it appears almost invisible. You see a dark thing. The moon is there, but it's not visible. The lights are off. There's a power cut on this side of the moon, right? The power cut which is facing the earth, there is no power. Power is only on the other side, so we are not able to see it at all. The moon is still present in the sky, but we just cannot see its illuminated side. So it is sun, moon in the center, and then the earth, right? So the bright side of the moon is towards the sun. The bright side of the moon is facing the sun. The dark side of the moon is facing the earth. So therefore, we do not see the moon on that particular night of Amavasya. Clear? No doubt? Chaliye, aage chalte hain. Why does the moon appear to change shape during waxing and waning? The sun always illuminates. That's why I'm saying I'm revising it in the slide deck. The sun always illuminates one half of the moon. And why am I revising it? Because I know there will be doubt. So I don't want you to finish this video with any doubt in your mind. The sun always illuminates one half of the moon. The moon revolves around the earth. As it moves, we see different portions of its illuminated half. So the same thing, 12 o'clock, 9 o'clock, 6 o'clock, 3 o'clock position. That's how it works. The sun is out there, and that's how it is illuminating different sides of the moon. Sometimes we see only a small portion of the lit position, which is the crescent moon, like this. Sometimes we see half of it like this. When we see the entire illuminated half, it is a full moon. After the full moon, the visible illuminated part gradually decreases, the waning period, until the next new moon, which will come after 14 days, which will be the Amavasya night. Remember, the moon shape does not actually change, only the portion of the illuminated side visible from the earth changes, right? Now I finished with the revision now. Now, another common doubt which is asked, is it in any way that the earth casts its shadow over the moon? Yes and no. The moon phases do not happen due to the earth shadow. That does not happen. That's an incorrect explanation. When in the rare occasion when the earth actually casts its shadow over the moon, that causes the lunar eclipse. And you in your life, see, unlike a solar eclipse, you can see a lunar eclipse with your naked eye. And I remember seeing someone last year. I may have some photographs. It is like blood red. The moon looks red when the earth's shadow is falling. That's a lunar eclipse, right? So that's something which we have studied last year already. So that causes a lunar eclipse. Now, lunar eclipses can only happen on a full moon day. It cannot obviously happen on an Amavasya when the moon is not visible. And solar eclipses can happen only on a new moon day, right? So please remember this fact. But they do not occur every month because of the small tilt of the moon's orbit, right? Otherwise, you would have a lunar eclipse happening every month. That does not happen because the moon's orbit is at a slight tilt with respect to the Earth's orbit around the sun. Please remember that the moon is moving around the Earth. So it's a very funny kind of a thing. That is, you have, if this is the Earth, you have the moon rotating around it, and the Earth is also moving around the sun and also rotating also at the same time, right? So there are these three kinds of movements which are taking place: the moon around the Earth on its own axis, and the Earth around the sun, right? So there are these three different kind of movements which are taking place. Now let's move to the whole concept of calendars. Now calendars are basically units of timekeeping. The day is based on the Earth's rotation. A mean solar day is exactly 24 hours, which is the average time between the sun reaching its highest point 2 days in a row. Now, if you see the Jantar Mantar kind of places, those were the earliest ways in which, depending on the shadow, you would actually gauge the time of the day or night. So, the highest point of the sun in the sky can be found by measuring the length of the shadows cast by an object during the day. The shadow is shortest when the sun is at the highest point in the day. Very simple. At 12 o'clock in the afternoon, right? And we have studied this. You should not find it difficult at all. We have done this in class 7. At 12 o'clock in the afternoon, sharp 12 o'clock, if you are standing outside in the sun is right on top of you, right? We call it in cameraman language, we call it top light, right? So it is top light, right? So you would find the shadow that is falling will be exactly below you, which means that the shadow is shortest at 12 o'clock sharp. At 1 o'clock, the sun would have come slightly this side, which means I will have a bit of a shadow out here. It will not be very long as compared to, let's say, 5 o'clock in the evening, when the shadows will be very long because the sun's light is falling at an extreme angle. It is going towards sunset, right? So the shadows will be very long at 5 o'clock. Similarly, at 7 o'clock in the morning, the shadows will be very long. But at 12 o'clock in the afternoon, when the sun is right on top, the shadow will be the shortest. So that's how you gauge the time of the day. Now, based on the moon's phases, one full cycle takes about 29 and a half days. This is for the month, and the year is based on the Earth's revolution around the sun, taking about 365.25 days. Please remember this figure because I will tell you something more about this. So this is about the day, month, and the year. This is how it is calculated. You need to remember this because this can come as a question in the exam. Now, activity 11.3, the same thing we have to do. You fix a stick and see the shadow which is formed by it, and you see it from 11 o'clock in the morning till 1:10 in the afternoon, and you will see at 11 o'clock it will be long, 12 o'clock it will be shortest, at 1 o'clock again it will be more or less the same as the 11 o'clock one. So you compare it on consecutive days, the duration between the sun's highest points is approximately 24 hours. Now the different types of calendars. The lunar calendar, let's look at it first. This is based on the phases of the moon, the phases of the moon. A lunar year is 354 days, okay, 354 days, that is 12 lunar months, which is 11 days shorter than the solar year, which is 365. So this is only 354, and this is the reason the seasons causing seasons to shift dates every year. So this is the lunar calendar. A solar year, which is based on the Earth's journey around the sun, is about 365 days long. The seasons repeat according to this cycle. So summer, winter, spring and autumn occur at roughly the same time every year because the seasons repeat according to the solar year, not the lunar year. A lunar year, however, consists of 12 months, each about 29 and a half days long. This makes a lunar year about 354 days, which is 11 days shorter than the solar year. Now, because of this difference between the lunar year and the solar year, a lunar month begins about 11 days earlier each year compared to the seasons. For example, if a festival falls in winter, what I gave you the example, see, certain festivals are based on the position of the moon, the most prominent of them being Eid ul-Fitr, right? So Eid ul-Fitr, you see that every year it will actually change the month in which it actually falls. For example, if a festival falls in winter one year, it will occur 11 days earlier the next year, 22 days earlier than that the next year after that. Over time, the same lunar month gradually shifts all through all the seasons. So it will keep changing because every year it will come approximately 11 days earlier. So that happens for festivals which are based on the sighting of the moon. For Eid, you wait for the sighting of the moon, and that's how you decide on which day you will celebrate Eid, which is the end of the period of the month of Ramzan. This is why the seasons do not remain synchronized with the same lunar month. A lunar month that occurs in winter today may occur in autumn, summer, or spring after a few years, because the lunar calendar is shorter than the solar calendar. I hope this is clear. Now, let's now come to the solar calendar. It is based on Earth's orbit. The Gregorian calendar is a solar calendar, the calendar that we follow. Now, the concept of a leap year. Since a year is 365.25 days, an extra day is added once in 4 years, and that's what makes it a leap year. February 29, to keep the calendar synced with the season. So every 4 years, we add an extra day because it is 365.25 in order to align it with the seasons. Now, lunisolar calendar. Now, Now, this is a combination of a lunar and a solar calendar. It primarily uses moon phases but adds an extra month, Adhika Masa, every 2-3 years to stay synced with the solar year. Many Indian calendars are actually lunisolar. Okay, Indian calendars as in which are followed in different states. Now, the Indian national calendar is a solar calendar. Its first month is Chaitra and the year begins on the 22nd of March, March 21 in leap year. Every 4 years it is March 21, otherwise it is March 22. You would find, if you see any of the almanacs and any traditional calendar which you may have at home, that would mention the month of Chaitra. Now, Uttarayan, now this is again something which you will need to know from the summer and the winter months, which is known as the Uttarayan, when the sun's apparent northward, when the sun is moving in a northward direction from December to June. Dakshinayan, with the sun's apparent movement which in the southern direction from June to December. Now these are two concepts which are followed in India, Uttarayan and Dakshinayan. Now, let's know about this particular scientist, Meghnad Saha. He was an astrophysicist who studied stars and their temperatures and developed a mathematical equation known as the Saha equation. The Saha Institute of Nuclear Physics in Kolkata is named after Meghnad Saha. He also chaired the Calendar Reform Committee, which was set up after independence in 1952. Based on the committee's recommendations, the Saka calendar was adopted by the Is it Saka or have I made a typo out here? 1 minute. I will check whether it is a Saha calendar. I am maybe wrong out here. Calendar was adopted by the Government of India in 1957 as the national calendar of India for official purposes, along with the Gregorian calendar. That's where the Chaitra thing comes in. Are festivals related to astronomical phenomena? Most Indian festivals are tied to moon phases and use lunar or lunisolar calendars. Diwali, new moon of Kartika. Holi, like Diwali is on the Amavasya night. Holi is on the Purnima night of Falguna. right? Eid ul-Fitr, sighting of the crescent moon after Ramzan, what I told you, right? So these are also, which is why, for example, in 2026, Diwali is coming, I think around November 10, November 9 or 10 something, it's coming. Last year it came in October, right? So every year it can change depending on the sighting of depending on the position of the moon and the lunisolar calendar, whatever it's indicating. Makar Sankranti or Pongal, which comes in December, this comes on a specific date, which is usually January 14 or 15, because it is based on the solar calendar, right? And falls on nearly the same date every year, which is why you could get a question that why is that Eid comes different dates every year, while Pongal or Makar Sankranti falls more or less on the same January 14, 15 every year. A solar sidereal calendar is a calendar in which the year is based on the Earth's revolution around the sun, and the positions of the sun are measured with respect to the fixed stars rather than the season. So this is the definition of a solar sidereal calendar. Why do we launch artificial satellites in space? Now, when we have a natural satellite like the moon, why do we launch artificial satellite? So the moon is a natural satellite. Humans launch artificial satellites into orbit. They orbit about 800 kilometers high and take roughly 100 minutes per orbit in order to do one orbit. What is the advantage? The advantage is to help in communication, navigation, the GPS, etc. that we use when we are going from place A to place B. All that is actually fed by the satellites, which are able to tell you that on this road there is huge traffic, take the alternate road. This all comes as a result of the satellites that we have sent into space. Weather monitoring, whether there will be rainfall, whether it will be a hot day, etc. Scientific research which will help farmers, etc. ISRO missions, Cartosat mapping and city planning. Then Astrosat was sent for observing stars. Then Chandrayaan mission, which was sent to the moon, missions to the moon. Mangalyaan, which was sent mission to Mars. And then you have Gaganyaan, etc., which are coming up for other studies in the outer space, especially the sun. Now, activity 11.4, spotting satellites. Look at the sky just after sunset or before sunrise. Search for a fast-moving point of light with a steady or flickering brightness. That, in most likelihood, will be an artificial satellite, right? Unless it's a comet. Artificial satellites are visible to the naked eye and move much faster than stars or the moon. Now, this is a very fascinating kind of a concept. If you ever have time, spend that kind of time looking up at the sky, you will find something very fascinating out there in the outer space. Then, Vikram Sarabhai, about who you should definitely read. There are books available on Vikram Sarabhai for the kind of work that he did for India's space research. Known as the father of the Indian space program, he pioneered the launch of India's first satellites. Vikram Sarabhai, a very eminent scientist, space scientist of India. With that, I've come to the end of this chapter, fascinating chapter, as I said, on our skies. I hope you found it fascinating as well. Please now read the chapter from your NCERT textbook so that it kind of reaffirms whatever you have understood. And now you need to underline it in your book with the help of these notes so that you are able to complement it well in order to prepare well for your examination. So remember to share the videos and also subscribe to CBSE with Sudhir. Tata, bye-bye. Thank you very much.